Welcome everyone to the 10th lecture into the lecture series on circuit and system. I'm Nikhil Kumar Nigam from EEE Department, Delhi Technical Campus. Today we will start with having a recap of what we have discussed in the last lecture, and then we will move forward on discussing the objectives of today's lecture. Let us start. So in the last lecture we discussed about systems. What are systems? Then to discuss the classification of systems, we discussed the present, past and reference instants, and then we discussed the time shifting and time scaling properties of the system. Let us once again have a recap. What is a system all about? System is made up of some physical components, and if these physical components are arranged in a systematic manner, then it can produce a desired output on the excitation with a certain input signal. Then such kind of arrangement can be termed as a system. We discussed the example of a generation system or a power system where we have the components of generating station. We have generating station, which is feeding input to the transmitting station or transmission lines. And then the output of this transmission line is fed to the distribution lines. And further, the output of distribution line is fed to the various localities in an area. So we are inputting the coal or any certain amount of energy. We are inputting coal. Then this coal is getting converted into electrical energy at this generating station. The electrical energy is stepped up to transmit to the distant places via the transmission line. Then the voltage at higher voltages is received in the distribution line, and then which is then distributed into the various localities. So the system made up of these three components is called a power system. So we saw that the systematic arrangement of these three components can constitute a power system. See, if I interchange any of these two components, say I bring this distribution line to there, and I take this generating station to this, then the coal cannot be fed to distribution line, and the output of distribution line cannot be fed to transmission system, and similarly the output of transmission system cannot be fed to generating stations. So this will not be a proper systematic arrangement. So in order for a system to work, all the components must be arranged in a systematic arrangement to produce the desired output on the excitation. Okay, so this is what a system is. So basically we can represent a system with a box. Say we have this system. Now this system processes the input. It will process the input and it will produce a certain output. Now this system can be represented in the time domain or in frequency domain. In time domain, the input and output signals are represented in terms of the variable of time or the function of time. Say in the input we have a signal xt, and in the output we have a function yt. Now this system can also be represented mathematically, that say we have this system system represented by this equation where yt is equal to 2 times of xt. It means this, that whatever the input is fed into the system, it will scale that input and will provide it to the output. that is in the output the input will be scaled and it will provided into the output. So this is the mathematical representation of a system. This is the graphical representation of a system. Then we discussed the present, past and future instants. Say for instant, I have t equal to 0. I am inputting the signal, or I am bringing some changes into the system at t equal to 0. Then this t equal to 0 will be the reference instant. This will be the reference instant, and any time before this instant, say t equal to -1, will be termed as the past instant, and any time after this instant will be termed as the future instant. So t equal to 1 will be the future instant, and similarly t equal to -1 will be the past instant. For example, let us take another example. Say at t equal to 2, I am bringing some change. So this t equal to 2 will be my reference input, or sorry, the reference instant or the present instant. Then t equal to 1 will be the past instant, and similarly t equal to 3 will be the future instant. So from 3, 4 and onwards, all are the future instants, and 1, 0, -1, -2 all are the past instant in reference to this. But in reference to this, this is future and this one is past. After the discussion on the instants, we discussed the time shifting and time scaling property effect on the on the classification of systems. Say we have this system yt to be equal to xt, and we have another system yt to be equal to x of t plus 1, and we have another system yt equal to x of t minus 1. Now we have these three systems. In this system we have this at t equal to 0, the equation will be y of 0 will be equal to x of 0, and similarly at t equal to 1, if I consider reference instant to be t equal to 1, then y of 1 will be equal to x of 1. Now this will be the reference instant. So this is x t equal to 1 will be the reference instant, and this equation is saying that the output at t equal to 0 will be dependent on input at t equal to 0. That is, output at any instant is depending upon the input at the same instant. But in this equation at t equal to 0, we have y of 0 equal to x of 1, and similarly at t equal to 1 we have y of 1 equal to x of 2. Now these two equations are saying that the output at t equal to 0 will depend upon input at t equal to 1. Similarly, output at t equal to 1 will depend upon input at t equal to 2. This means that the output of the system is depending upon the future inputs. So this equation is saying that we have a system where the output is depending upon the future inputs. This equation is saying that we have a system where output is depending upon the present inputs, and similarly in this we can have y of -1 to be equal to x of 0, and y of 0 to be equal to x of, sorry, this has to be -2, and this will be -1. Let me erase it out. If I substitute y of 0, then it will be -1. Now this says that instant output at the instant t equal to 0 will be equal to the input at t equal to -1. That is, the present output will depend upon the past values. So this system is saying that the present output will depend upon past values. This system is saying that present output will depend upon future values, and this system is saying the present output will depend upon present input only. So we can on the basis of how the input signal is being modulated and translated into the output, we can classify systems. So let us see. So the objective of today's lecture is to classify systems on the basis of how the input is dependent on the output, whether the input depends upon the past values, present values, or future values. Let us see. So on the basis of it, we can classify our system into static and dynamic system, causal and non-causal system, time variant and time invariant system, linear and non-linear system, stable and unstable system. Well, we have further more classifications, but as per the scope of the syllabus, we will discuss only these classification of the system. So first we will discuss the static and dynamic systems. So let us start. Static and dynamic system. So a static system is one, or I should write, in static systems, the output of the system is dependent on present input only. Present inputs only. That is, if the output is dependent only on the present inputs, then we say the system is static. We'll discuss further more on it, but first let us have a definition of dynamic system as well. But in dynamic system, the output, or I should rather say the present output of the system is dependent on past, future and or present values, or present inputs. So in dynamic system, the output of the system is dependent on, it may be dependent on past inputs, future inputs, or present inputs, or all of them. That is, in this, the dependence of the output, is dependent on past, future, and present inputs. Let us have some example of it. In the static system, I said that output will be dependent only on the present inputs. It is only possible if the system does not have any memory. So why it is also termed as memoryless system. Memoryless systems, also termed as memoryless systems. But as the in dynamic system, the output is dependent on past, future, and present inputs. That means to store the past values of the input or to predict the future values of the input, the system must have memory. So it is memory system. The system has memory, but this system does not have any memory. We can better understand this by performing some numericals on it. So let us start. Say, consider this, we have this first example, yt is equal to 2xt, and we have to comment whether this system represented by this equation is a static system or a dynamic system. Okay, so to check this, whether the present output depends upon past, future, or present values, we will calculate the values at different instant of time. Say at t equal to 0, say at t equal to 0, this gives y of 0 to be equal to 2 times of x of 0, 2 times of x of 0. Similarly, at t equal to 1, we have y of 1 to be equal to 2 times of x of 1, and similarly at t equal to minus 1, we have y of minus 1 to be equal to 2 times of x of minus 1. Now this equation says that output at t equal to 0 is equal to 2 times of input at t equal to 0. That means the present input is dependent on present output. Similarly, this equation says that output at t equal to 1 is equal to 2 times the input at t equal to 1. It means this, the present output is dependent on present input. And similarly here we have y of minus 1 equal to 2 times of x of minus 1. This says that the output at t equal to minus 1 is dependent on the input at t equal to minus 1. So at every instant we can clearly see that the present output is depending on present input. There is no dependence of the output at the past and future values. So we will say the system is static. So or I should write, as we can say, as above equations suggests that output is depending on present input, so the system is static system. So the system is static system. Similarly, let us see this example. In this example, we have a system represented by this equation where yt is equal to x of 2t. So let us again calculate the output at various instants. Say at t equal to 0. Let us calculate the output at t equal to 0. At t equal to 0, we have y of 0 equal to x of 0. Now this equation is suggesting that the present output is depending upon present input. Let us put some more instants. At t equal to 1, we have y of 1 equal to x of 2 into 1, which will be 2. So this equation is suggesting that present output is now dependent on future inputs, whereas the initial equation was saying that the present output was dependent on present input, but now we have present output dependent on future input. Similarly, let us check the system at t equal to minus 1. We have y of minus 1 to be equal to x of minus 2. Now this says that the output at minus 1 is equal to the input at minus 2. That is, the present output is depending on the past values. So these three equations are saying that the output is depending upon present input, output is depending upon future inputs, output is depending on past inputs. So as the output is dependent on past, present and future inputs we can say that the system is dynamic system. So as we discussed earlier, we can see here we have time scaling here. So we discussed in the last lecture, whenever we come across a time scaling in the output, or sorry, in the input, we can directly say the system to be dependent on present and future values. So the system is dynamic, and over here there is no time scaling, so we can directly say the system is static. Let us check these systems for being static and dynamic. Let us check the output at t equal to 0. From this we have y of 0 to be equal to x of 1. Similarly, at t equal to 1 we have y of 1 to be equal to x of 2, and at t equal to -1 we have y of -1 to be equal to x of 0. Now all these equations are saying that the present output is depending upon future input. Over here also present output is depending upon future, because over here the reference instant is t equal to 1, so t equal to 2 will be the future. So we can say the present output is depending upon future input. Similarly, at t equal to -1 we have present output equal to future input. So all these equations are saying that output is depending upon above discussion. From above we conclude that output is dependent on future inputs. This means the system is dynamic, as the output is not depending on input, so we will say the system is dynamic. What is the thing to be noted here? We have time shifting here. So whenever we come across a time shifting in the input, and when there is no time shifting in the output, then we will say the system is dynamic. Similarly, let us comment on this. At t equal to 0 we have y of 0 to be equal to x of 0 minus x of -1 plus 3x of 3. Let me write it with different color. So this equation is saying that output is dependent on present input, past input and future input. So this one equation or one time instant is sufficiently indicating us the dependence of output on the present input past input and future inputs. So we can directly comment that the system is dynamic. Or this can also be concluded from here that we have inputs which are time shifted. So this time shifting brings the dependence of output on the past as well as on the future. Let us proceed further. Over here we have two more systems. Let us discuss first system, this one. We have y of t to be equal to the integration of xt dt. That is, the output is equal to the integration of the input. But as we can see, there is no time shifting or no time scaling in the input. So that result, from that result we can conclude that the system is static. But one thing we should note, that there is a presence of integration sign. So let us first see what is integration. Say we have this curve of yt, say this curve is of yt, and over here we are plotting xt. Then if I take the integral from x1 to x2, this means I am calculating the area under the curve between the limit x1 and x2. Now the area can be calculated only by knowing the values at x equal to 1 and at x2. So if I have the knowledge, that is, the area can be calculated only by having the information about the past and present. So if I have the information about the past and present, I can calculate the area. So it means this, while integrating any function, I need to know the values of the values in the past as well as in the present. So this means that this system should be a dynamic system. So we can create certain conclusion from it. So system with integration are dynamic in nature. Dynamic in nature. So whenever we come across an integration sign into the system defining equations, then we would directly say the system is dynamic. So let us now discuss this. Here in the system we have yt equal to x dash t, where x dash means the derivative of xt with respect to time. The derivative means that to calculate the derivative dxt by dt, I need, when h tends to 0, x of t plus h minus x of t divided by h. This is the definition of derivative, h tending to 0, where x of t plus h minus x of t divided by h is to be calculated. Now if we see, if I consider this to be present, this will be future, or if I consider this to be present, this will be past. So from this I can conclude that the output will now be depending on the past as well as future or present. So I will comment that the given system is as dynamic. Or we can draw some conclusion. The conclusion could be system with derivative equations are dynamic in nature. Dynamic in nature. A question must be coming in your mind that why are we studying about the static and dynamic systems? Because the scope of the syllabus is this, that we will be only synthesizing the systems or circuits which are static in nature. We will synthesize systems with static properties only. So these are synthesizable. Let us proceed further. Let us take two more examples. A very interesting one. This particular example, this one and the last derivative one, appeared in the last year sessional examination, university sessional examinations. We have yt to be equal to x of sine t, and we have to comment whether the system is static or dynamic. See here, let us say at t equal to 0, let us calculate y of 0. So y of 0 will be x of sine 0. X of sine 0 will be 0, as sine 0 is 0, so x of 0. Now this equation is stating that the present output is dependent on present input. Let us check this on different other time instants. Say at t equal to pi. T equal to pi, we have y of pi to be equal to x of sine pi, where y of pi means y at the interval or at the instant 3.14 and x of sine pi would be 0. Now this equation is saying that the future input or future output will be depending upon past input. So from this we can conclude that the present input is depending upon past inputs. So we will say that this system is dynamic in nature. By dynamic, I mean that it must have certain provision to store the past values. To calculate the y at 3.14, it must store the value at x equal to 0. Similarly, let us discuss this numerical. We have yt equal to e raised to power x of t. So let us check at different instants. At t equal to 0, we have y of 0 equal to e raised to power x of 0. Now this clearly shows that present input is dependent on present output. Present output is dependent on present input. Similarly, if I change the time interval to t equal to 1, then the equation will be y of 1 will be equal to e raised to power x of 1. Now this shows that the present output is dependent on present input. Similarly, at t equal to -1, we will have y of -1 to be equal to e raised to power x of -1. That is, the present output is dependent on present input, and hence from this conclusion we can conclude that the system is dynamic. not dynamic, in fact it is static, because every time the present output is dependent on present input, present output is dependent on present input, present output is dependent on present input. So this system is static. We have a very similar question. Suppose we are given that y of t is equal to e raised to power t into x of t. This time present output is equal to e raised to power t times xt. Let us calculate the values at different instants. So at t equal to 0, we have y of 0 equal to e raised to power 0 into x of 0. Now this will be constant. If it is constant, I can say the present output is dependent on present input. Similarly, at t equal to -1, we can say y of -1 will be equal to e raised to power -1 into x of -1. Now e raised to power -1 will be a constant. If it is constant, this means the present output is dependent only on present input. Also at t equal to say 1, we have y of 1 to be equal to e raised to power 1 times x of 1. Now from this equation I can also again comment that present output is again dependent on present input. So from all these three equations I can say the system is always depending upon present output and present input. The present output is dependent on present input, present output is again dependent on present input. So the system is again static. So I will comment here that the system is static. This is a static system. Why are we calling it to be static? Because we can see that in the input term we do not have any kind of scaling or shifting. But if there would have been any kind of scaling or shifting, then the system would have not been the static system. Similarly here we do not have any scaling or shifting, so why the system is coming out to be static. But this system is coming out to be dynamic because there is scaling of the time due to this sign. So we have scaling. Now similarly I can also write that y of t equal to x of e raised to power t. You need to comment on this whether this particular system will be static or dynamic. We shall discuss it in tutorials. So let us summarize today's lecture. So in today's lecture we discussed system to be static and dynamic. A dynamic system depends upon present only, not present only, present and past only, present and past, present and future, or past and future values, future inputs. Whereas a static system will always depend only on the present inputs. And we also discussed that any kind of time scaling and time shifting in the input signal, it will make the system to become dynamic. So I guess that's it for today's lecture. So thank you so much for listening to the lecture. You can mail me your queries at n.nigam@delhitechnicalcampus.ac.in, or you can WhatsApp me your queries on this number, or we can meet and discuss your queries in tutorials. Till then, take care. Bye bye.